I'm sure you've heard the news about nuclear explosions. They often dominate headlines, capturing the world's attention with their sheer destructive power and the fear they instill. But what really happens when the unimaginable occurs? Let's break it down. Understanding the science behind these explosions can demystify the process and help us grasp the magnitude of their impact. Alright, let's get to it. At the heart of a nuclear explosion is a process called nuclear fission. This is the fundamental reaction that powers both nuclear reactors and nuclear bombs. Imagine it like a chain of dominoes. When you topple one, it sets off a rapid cascade, right? This is a simple yet powerful analogy to understand the chain reaction in nuclear fission. In nuclear fission, an atom of uranium or plutonium gets hit by a neutron, and it splits. This splitting is not just a simple break, it's a violent release. This split releases a tremendous amount of energy and more neutrons. These neutrons then hit other atoms, causing more splits. Each split releases more energy and more neutrons, perpetuating the cycle. It's a chain reaction that goes from zero to boom in milliseconds. The speed and intensity of this reaction are what make nuclear explosions so devastating. But wait, there's more. The process is not as simple as just splitting atoms. To create a massive explosion, you need a critical mass of fissile material. Think of it like a crowded party. If there aren't enough people, the party won't kick off. If there's not enough people, the party won't kick off. Similarly, if there isn't enough fissile material, the chain reaction will fizzle out. But once you hit that sweet spot, things get wild. In a nuclear explosion, this party is controlled by precise engineering to ensure all conditions are met. Scientists and engineers meticulously calculate the amount of material needed to reach critical mass. And then comes the dramatic part. The culmination of all these reactions results in an explosion of unimaginable scale. The energy released is so immense that it creates an immense fireball, shock waves, and deadly radiation. The fireball can reach temperatures hotter than the surface of the sun, and the shock waves can flatten buildings miles away. It's like setting off a chain of fireworks, but on a awe-inspiring and terrifying, a stark reminder of the power harnessed within the atom. So there you have it. The science behind nuclear explosions is a complex interplay of physics and engineering. The science behind nuclear explosions simplified. Stay curious, stay safe. Understanding these processes not only satisfies our curiosity, but also underscores the importance of handling such power responsibly.